So now that we've done that, let's move on to the next step, which is the second layer. Now, if you're good at F2L, you might want to try combining the corner and the edge for F2L, and anything that you know on F2L on 3x3 will also relate directly to this cube. However, it's a little harder to do F2L when you have pieces that have splits and such. So if you want to skip the F2L thing and just do the normal, that works fine. So for this particular one, we're going to have green and yellow, and I have a green and yellow here. So I'm just going to do the normal algorithm from the basic 3x3 beginners method, and it works just nicely. This one's already solved, so we got lucky there. This one's already in there, but it's kind of faced the wrong way, so I'm just going to take it out and put it back in the correct way. As you can see, it matches up very nicely, and I'm putting it in. This particular step of the Ruben King Cube is pretty much exactly like the regular 3x3, at least the beginner's method. And so this really shouldn't give you that much trouble. Just make sure that the two centerpieces, the colors that you're putting in, match up with the centerpieces on either side. Like so. So we should have the first two layers done, and now we're getting to the last layer, which is the hardest part of the Ruben King, but it's not impossible, so don't worry about it. We're going to solve it right now. So the first thing you need to do is you need to get the cross on the top, which is actually very simple. The only thing that you need to take note is that on a normal 3x3, you're only looking at the top color. But on this Ruben King, the top color actually consists of two colors, white and blue, or whatever other color you're using as your top face. So when you're looking for, you know, your cross, you're not going to have white, 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 white. It's going to be blue, blue, white, white. Right now, I don't have any blues or whites. So I'm just going to do an algorithm. Now, at first glance, it might seem that I only have one edge because white. But remember, it's white and blue. So since I have the blue here and the white here, this is actually the L, as you can see. So I'm going to do the algorithm for the L, and now I have the cross. If you had the bar situation, just make sure that you do the algorithm for the bar instead of the L, and you should be fine. Now, the center at this point shouldn't be oriented. If it is, great. If it's not, don't worry about it. Orienting the very last center is the last step of the entire puzzle. So if this is messed up right now, don't worry about it. But what you do need to do is make sure that you don't pay attention to it. Because if you pay attention to this particular center, unlike all the other ones where the pieces have to match the center, on this one, on the last layer, the pieces aren't supposed to match the center. They're supposed to match these edges right here. So if the center is correct, great. If it's not, that's kind of a good thing. Just make sure that you don't let it distract you. So now that the edges are oriented correctly, the next step is to orient the corners. Now what you can do is you can go ahead and do the 3x3 layer by layer method, the beginner's method, and it might work for you, but you're probably going to hit a snag later on. You're going to have some kind of parity case. And that's not good. So what you're going to want to do is you're going to want to do a 2-look or a 4-look style of solving the last layer. If you don't know how to do 2-look or 4-look, I have a tutorial on my page. It's called How to Solve a Rubik's Cube in Under 1 Minute, and that will teach you a basic method. It won't teach you the full 4-look method, but it will teach you a basic method on how to solve with that technique. And that's actually a good way to learn faster method. So if you don't know how to do a 4-look, you really need to look up that video. You can try to do 3x3 layer by layer on this, but it probably won't work. So I'm just going to go ahead and continue with the standard 4-look. So as you can tell, we already oriented the cross, the edges anyway. So the next thing we're going to do is orient the corners. So in this case, I have the little Superman one where you have two facing this way and two facing away. So I'm going to do the algorithm for that. And now my entire top is oriented, and that is basically all we have to do for the orientation. So at this point, the next thing we're going to do is we're going to, now that we oriented everything, we're going to orient the corners, or permute the corners rather. So to permute the corners, all you have to do is look around until you see one that has a split and a solid next to each other. These are two solids, so they won't work. These are two solids, so they won't work. These are two splits, so they won't work. And these are two splits, so they won't work. If you get that particular situation, all you need to do is a basic corner cycle, and eventually one of the pieces will work out. Like this one, for example. You have a solid and a split, as you can see. Solid, split. I know that the glare makes the orange and the yellow look similar, so this is a little bit easier to see in this position. So here's a solid yellow, yellow, and orange. And also pay attention that the split lines up with the center, and the solid is also in the correct position. If for whatever reason it's like this, where the split does not match up, try giving it 180 degrees and you should get some kind of matching situation. Now, if you do any other kind of PLL stuff, you can apply all the PLL stuff to this also. It's just harder to visualize when you have all these random colors. So I recommend doing a for look for the Ruben cube. It's a little bit easier. So now we're going to be able to permute all of the corners. So this is a basic corner cycle. Just like that. And obviously they don't look like they're matched up, so I just need to rotate them until they all look good. So as you can see, that's oriented, and that's oriented, and that's oriented. Now, I got a parity case here. If you don't get a parity case, what you'll probably have is either the H-Perm, the Z-Perm, or one of the edge cycles. So if you get the edge cycle, just do the edge cycle like normal and it should work out. If you get the Z-Perm, do the Z-Perm. If you get the H-Perm, you get the H-Perm. I'll put all of those in a link below, and I will come back to those after I hit this first parity case. So here's the parity case. A lot of times what will happen is you'll have two pieces that need to be switched, two edges that will need to be switched. And what normally happens on a 3x3 is that, well, first of all, this doesn't happen. You can't really have two edges that need to be switched and the entire thing is solved. It doesn't really work that way. But on a Ruben King you can, because of the fact that you have duplicates, as I mentioned before. So all we need to do is find the duplicate of either the red or the yellow. So this one, for example, works nicely. I can give this a rotate, and now the red is on top. The other option is to take this yellow, give it a rotate, and now it's on top. Basically what you need to do is you need to take the duplicate of either of the pieces on the bottom, rotate it twice so that it's on the top. So now we're just going to do a simple edge cycle. Now, all you have to do at this point is return the original piece back down by giving it a 180 degree turn. It's useful to memorize, or at least keep note, of which piece you rotate at the beginning so that you know which piece to rotate back down to the bottom after you've completed the edge cycle. That's how you fix the parity case. Another scenario that you can get is a clockwise edge cycle, like so, where these three edges need to be moved in a clockwise rotation with each other, and do this algorithm. So this is one of the other scenarios you can get. This is a pretty straightforward edge cycle. So I'm just going to go ahead and do this now. This is a counterclockwise edge cycle. This is another case that you can get. This is the H-Perm. It's where pieces need to be switched in kind of an opposite. Just like that. Another scenario that you could get is a Z-Perm, where these two pieces have to be switched, and these two pieces have to be switched. Just put one and the other on the right and front, and the other pair on the left and back, and do this algorithm. Just like so.